So thank you very much. It started. Thank you.
Okay, thank you. Thank you very much, good doctor. And good afternoon, everybody. How are you?
Good in yourself?
Okay, no,
Good afternoon. Well, thanks, and you?
very good, man. Good Saturday. Mm, as always, let us get started. And as always, please feel free. This is your session. This is more about you than anybody else. Stop me or stop us at any time if you feel like you are lagging behind. Then we will try to explain it using whatever approach until you understand. So feel free. Now, any question from the previous sessions, assuming that you try to revise this, and that's all. If there is anything that you are still not sure of, anything that we didn't explain to your satisfaction, this is still time. You can just ask me anytime, anything.
Nothing from my side, sir.
If Are you okay, Sipo, so far? So far, so good. Pala, good. Now, today, the topic, or always, all our topics, they are self-explanatory. Today, it will be about, that is what? 3 topics. And they are all straightforward. But please, dear student, try and what? All these topics, try and use your prior knowledge. I mean, if you want to make sense of all of this, read the topic and say, this is the topic. But now, can I use my prior knowledge, whether secondary, primary, or preschool, or whatever? Then from there, take it from there. Like the first topic there, it says the arc length. And what we mean by finding the arc length, that is the length of, is either be a line segment if that curve is a line, or it can either be what, just the length of any function. Let's say you have got this. This is your Cartesian plane. Let's try. This is the Cartesian plane. This is the x. This is the y-axis. It doesn't matter. Then from there you have got this line segment. Say this is straight, and somewhere here is 4. And say this is A here, and this is B. What will be the length of AB?
4 units.
Can anybody tell us what will be the length of AB?
4 units, sir.
Come again, 4 units. And how did you get it at 4 units?
The x value of 4 minus the origin of 0.
Yeah,
B minus
because
A.
that's perfect. Because this is a horizontal line. It's a horizontal line. So to find the distance, to find the length of any horizontal line, it will be x on the right, subtract x on the left. It's just like if you draw a line segment like this. Say this is 2, and this one here is 8. This one is 8. Then say this is C, this is D. Then it will be, what is the length of CD? You can just simply call it what? Arc length, whatever. But because it's a horizontal line, or because it's a straight line, then we are going to call it a line segment. What is the length of line segment CD? It's very simple. It will be x on the right, which is 8, minus x on the left, which is 2. Therefore, it will be 8 minus 2, which is 6. It's straightforward. Now, the same story, even if you can draw a line segment like this, if you can draw a line segment like this, straight line like this, straight line, can we find its length? I mean, if we know the coordinates here, if we know the coordinates of this point, and we know the coordinates of this point, the coordinates of this point, say, is what? 4 and 1. And the coordinates of this point, say, is 5 and 4. Can we find the length of this? Say this is A again, this is B. Given the coordinates of A and the coordinates of B, can we find the length AB? Yes, there's a formula for that. We know it. There's a formula for that. But now, today, we are going to take this further. Take this further and say, can we find the length of any now? Because these are standard geometrical objects. So can we find the length of this? Hopefully you can see it. Can we find the length of this? Now, this is not standard geometrical object. It's not what? It's not an arc of a circle, because with an arc of a circle, we can find it using radians, depending on whether because remember with that radians, it will depend on whether you have got the angle subtended at the center and the radius of that circle. But now this is not in a circle. It's like this. So now we are now going to try and find the length of now part of a function like this, part of a curve like this, which is not standard. Hopefully that makes sense. If you understand it from that point, then it should be very simple. Why? Because we have a formula for that, which is good news for you, because those formulas, you are allowed to use them in the exam, in the test, or whatever. So let us get started now. Say again, you have got a Cartesian plane like this. There is y here. Then you have got what? Say y is equal to 2x. Can you sketch this? Y equal to 2x. Let's say 2x plus, let us make it say 2x plus 3. Can you sketch the straight line? Yes. The y-intercept, it will be 3. The x-intercept will be minus 3 over 2. Therefore, it will be a straight line like this. The y-intercept here is 3. The x-intercept here minus 3 over 2. And the question is, find what? Find the arc length. The arc length. If you can't see, hopefully you can hear me. Find the arc length of this. 2x plus 3. From where x is equal to minus 3 over 2 to where x is equal to 0. Let us pause and think about it. They say this is your function, this is your curve. Now they say find the arc length, or the length of an arc of this from where x is equal to minus 3 over 2, that is this, to where x is equal to 0, that is here. Meaning we must now find the length of this. The length of this. Can we find it now, even without integration? The answer is yes. Why? Because this is forming a right-angled triangle here. This is a right-angled triangle. Therefore, from here to here, that is this side, is the hypotenuse. Then from that theorem by Pythagoras, we know that this side squared, it must be equal to this side squared plus this side squared. That's all. So you can just say, okay, let this be whatever, name it whatever, says L. Therefore, it will be L squared from that theorem by Pythagoras. It must now be equal to this squared. And from here to here, if x here is minus 3 over 2, therefore from here to here is 3 over 2. Therefore, you square it, it will be 9 over 4 plus this side, y here is 3. Therefore, from here to here is 3. This side squared, therefore it will be 9. Then obviously, this it will be what? Say 36, because it will now be multiplied by 4 over 4, which will be 36 over 4. 36 plus 9 is 45. Therefore, this will be 45 over 4. Therefore, L now is equal to the square root of this. Let me just get the calculator. What is the square root of 45 over 4? The square root here, more or less, it will be 3 comma what? We write it properly, 3 comma what? 3,5 units. It will depend on whether you are using centimeters, kilometers, or whatever. Therefore, from here to here, it will be this. Any question, even if you can use that other formula, it will be this. This is without using integration. But now, if you are now going to use integration, because not all are will be like this. As we've said, we can just say what? Find what? The arc length of y equal to x squared. Say from where? From x equal to 0 to maybe x equal to 4. Where you will now like this. Hopefully you can see. Hopefully you can see. X here is 0. X here is 0. And x here is 4, meaning y is 16. Then this, it will be 4 and 16. Then you are now asked to find the length of this part. The length of this part. It doesn't form a triangle. It doesn't form anything. Therefore, this approach cannot work. So what will work? Let us start with this one. Then from there, take it to this one. Let us start with what we know and see whether that formula will indeed give us this. And now from there, we can now generalize it, because what is important is what? Use the formula to do as many problems as you can so that you get used to that formula. Unless the big elephant is what? Your integration knowledge. Because at the end, you must integrate something. And in that process, it may be by parts. It may be using integration. You may be forced to use any other technique of integration. So therefore, you must know your integration very well before we can even talk about the applications. So now, what is the formula for finding the arc now of a length? Now, this is the formula. You know it. You saw it. It will be S equal to 1 over B minus A. And what are these B? What are these A? These are the limits. That function or that arc, it will be from A up to B. And now A here is minus 3 over 2. 2, 0, x equal to 0, meaning B is 0. So it will now be integrate again from A to B, and these are x. This is x, this is x, this is x, this is x. Then obviously the variable of integration, it will be dx. It will be dx. If your function is given as x equal to in terms of y, x equal to in terms of y, then this it will be y, this will be y, this will be y, this will be y, this will be dy, and this, the integrand, it will be in terms of y. So now here, they say now here, what is this now? It will simply be the square root of, I'm talking about a formula, 1 plus dy dx all squared. Hopefully you can see this. It will be this. Let me just bring this closer. It will be this. That is a formula. Hopefully you can all see it is clear. Now, what is this now? What is, it will not be equal to 1 over. They say this is from where? From x equal to this up to this. As we have said, the b is the upper limit, meaning it will now be 0. Minus a is the lower limit. It will now be minus 3 over 2, which is just 3 over 2. Then it will be 1 over this fraction. Therefore, it will be the reciprocal. Let us just write it, because it's 0 minus negative. Therefore, this, it will just be what here? We have said is how much? It will be 2 over 3. It will be this. Because it's gone, we have said is 0 minus negative this. Then to where? From minus 3 over 2 up to 0. The square root of what? It will now be 1 plus. Then you differentiate your f. You differentiate your y, because remember here, this is our y, or you can write it as f of x. It doesn't matter. So you differentiate this, which will give you 2. Then it will be 2 squared. Don't forget, with respect to x. If you can't see, you please tell us. Then this becomes what then? This becomes 2 over 3. Now you can just simply, it will be 4 plus 1, 5, the square root of 5. Then we can even take it out, because it will not be what? The square root of 5 by what then? By what? By just, because this is just, you can just take it out, x. From where to where? From minus 3 over 2 up to 0. Then it will be this. Then at the end, it must give you this. Otherwise, something here is wrong. Then it will simply be, you replace x by 0. Therefore, it will be 0 minus negative this. Therefore, at the end, it will be 2 over 3 by the square root of 5 by what? Because it will now be 0 minus this, which will now be 2 over 3. And then from there, you can just check whether indeed it is, this is equal to this. Let's just check. What will be the answer here? It will just simply be 4 the square root of 5, fraction 4 the square root of 5 all over 9. What is the answer? The answer, no. Why is it not the same? Is there anything that we didn't do properly?
Sir, I think in the textbook, the formula for S doesn't include the 1 over B minus A. That's for the mean and the root mean square.
I confused this with the next topic. The next topic is what? Is the mean value.
Yeah.
It doesn't have this one. I confuse these two because the next formula is the one that is the mean value is the one that has got what? This one. And you can even see here, if you understand it properly, it will tell you that no, it will not make sense at all. So then this is out, this is out, this is out, this is out, this is out. So the answer is it should be this one. So which is how much? Which is 2 the square root of 5 over what? Over 3. That's correct? Yes? No, still it doesn't. What is happening? We have said from minus this up to this.
So the second or the last line, why is it the reciprocal 2/3 rather than 3/2? Because if you do 3/2, it's the same answer.
Again, is you replace x by 0, it will be 0 minus, and then here again, we made another mistake. This is not the reciprocal, it is this.
And now the answer is the same.
That's right. Then now the answer is the same. I was even thinking of the reciprocal because we have reciprocated here and here, then automatically then I said the reciprocal, which is wrong. Then you can see that, oh, this formula is correct. It's giving you the same answers. Then you can take it and use it in any problem. But now again, the big elephant, it will be, can you get this? Because from here to here, because it will not be the integrand, the integral of this, then you must now carry this one. Hopefully, it ends. We can look at another problem. Just clean this. We can look at another problem. It doesn't matter. Y equal to whatever, say x squared. Then I say, don't forget the question is find the arc length of this from where? Say from x equal to 1 to x equal to whatever. Say x is equal to 4. Very fast. Can you try it? Very fast. Don't forget the question. Find the arc length or the length of an arc of this curve y equal to x squared from where x is equal to 1 up to where x is equal to 4. Then from there, once you get it correct, then we can look at something else now, because now you know now. It will simply be s equal to the formula. We mustn't make a mistake again. It will not be simply, let me just check. It will be what from here? From where to where? From 1 up to 4. The square root of 1 plus dy dx. That is dy dx all squared with respect to x. And this is y equal to this. And what is dy dx here? Dy dx here is 2x. You see, dy dx is 2x. Then this, it will be from 1 up to 4, the square root of 1 plus, but do we even have to remove the brackets here? Do we even have to square it here? Okay, then I just square it. It will be 1 plus 4 x squared dx. As we have said, now the big elephant in the room, it will be, what is the integral of this? 1 plus x squared. Is it going to be the general power rule? Integrating this. Which technique it will be this one? I'm asking you, which technique it will be this one? Anybody? Because if here, if you had x here, then it's going to be simple. It's going to be the general power rule. All what you need is what? You would say, what is the derivative of 1 plus 4x squared? The derivative of 1 plus 4x squared is, because now our function now, it will not be what? I'm saying, if you are trying the general power rule, I'm not sure which number is it in your booklet. Then the derivative here, it will be 8x. I'm saying if we are trying this, if you are trying this, the general power rule, if you are trying the general power rule, it will be this. Because your n is going to be half, because this is half. This is exponent half. Your n is going to be half. And what is your function? Your function here is going to be 1 plus 4x squared. Then you immediately differentiate it. And then from there, compare the x with the actual derivative of this. And the actual derivative of this is 8x. Therefore, you're going to compare the actual derivative, which is 8x, with what is here. Then you can see that, oh, they differ by a constant factor. They differ by 8. Then we are going to write 8 here and write its reciprocal outside, which is 1 over 8. Therefore, it was going to be very simple. But now, you cannot just simply insert it. You can only insert a constant, not a variable of integration. Then out. The general power rule is out. Then which one is in? Hopefully that makes sense. And you did that before. All what we need right now is just simply to refer you to that formula. Remember, this is from 1 up to 4. Then it will now be what? Then if you see this, you can see that we don't even have to square this. We don't even have to square this. It will just be 1 plus 2x, then you square, then that's right. You don't have to remove the square. Then you can see that, oh, if I say this is my f, if I choose this, not everything inside this f. If you choose everything inside the side, inside the sat sign, if you choose everything inside the sat sign as f, then you are going to then you will be using the general power rule, which we saw it can work. So now here, which taking it will work now. That is where now you choose this one as your f, and this one as your a squared. That is now, we will now be trying this one now. We will now be looking at this. We will now be looking at this formula. And I'm not sure which number is it. I'm not sure about the numbering in your book. But it will be this one. So your f now, your f is 2x. And then if you differentiate 2x, that is, this is f, you must differentiate it, and it must give you this. And don't forget, here there is 1. Then if you differentiate this, you are going to get 2. We are now going to compare that 2 and what is here. Then you can see that, oh, they differ by a constant factor. You can multiply 1 by a real number and get the other one. So here, then we just have to write 2 here, which is the actual derivative, because our f now is 2x. This is 2x. And its actual derivative is 2. Therefore, this is exactly this one. And then to cancel these 2, we know, then you're just going to write its reciprocal outside. And this 1 over 2, it will not be multiplying everything. It will not be multiplying everything. Any question up to this far? Any question? So which rule is this now? The one that we have just used here. I'm not sure what is it in your booklet, but the answer, it will not be what? A squared over 2. Let me just write it. It will not be half. Okay, let me just write the formula. Let me just write the formula from there. You will substitute. But don't forget, the half is outside. This half is outside. The formula, it will be a squared over 2. What now? Ln of the absolute value of, that is f of x. I'm not sure which number is it in your booklet. That is plus the square root of a squared plus f of x all squared. I'm not sure which formula is it in your book. Then it will now be this. Remember, a squared over this is only multiplying this first term. Then it will now be plus f of x over 2 square root of a squared plus f of x all squared. Then from there, then this is the answer. Then from there, you will now bring in the inbring. Bring what? That is 1 up to 4. But don't forget, there is this half outside. The answer for this, you just have to plug it in here. What is A? A squared is 1. A squared is 1. Therefore, this, it will now be 1. Now, what is f of x? F of x is 2x. A squared is 1, meaning this. What is f of x here? F of x is 2, then it will be 4x squared, because it's 2x all squared. Then plus, what is f of x? F of x is 2x. What is a squared? A squared is 1. Then it will be, that's right, therefore it will be what? Now 4x squared. Now, then you will now evaluate this. Open 2 brackets. In the first bracket, you replace x by 4. You get the answer, minus. In the second bracket, you replace x by 1. But don't forget a half. Don't forget a half. But as we have said, the big elephant is moving from this to this. That is now integrating this integrand, which will be any integral technique. It can be by parts, or it can be by this formula, so on and so forth. And in some instances, you may find that your f of x is not a monomial. It's not 2x. It's a binomial. Maybe it's 2x plus 3. Maybe it's 2x plus 3. Meaning, maybe your function here, it was not just x squared, it was y equal to x squared plus 3x plus 4. Now, when you differentiate that, because this is the derivative all squared, when you differentiate, then this is not just 2x, it's 2x plus, it's 2x plus 3, all 2x plus 3 all squared. But it will still be the very same formula. You just have to replace x now, f of x here by 2x plus 3. Then here, because it's not f of x, it's f of x all squared. It's f of x all squared. That's good. So then it will be 2x plus 3 all squared. F of x. Remember, this is not our f of x. This is y equal to. And then this formula is talking about, that's right. Any question thus far? Any question thus far? Yes, do you have a question? Anybody? Any question? Okay, now let us just take this and do another one. Say another one. This one, let you try it. Say y equal to how much? I think I saw something in your book. In your book, they used what? Say, let me just check. In your book, they used cos. So here, let us use something else. Say x squared over 8. Yes, I also saw this in your book. Minus ln x. They say this is your curve. Y equal to this. Find the length of an arc of a curve of this from, let us just twist it around. Say x is equal to 2, from x equal to 2 to x is equal to 4. It's the same example. We just twisted what the limits. I think I just changed the limits. So that is not exactly what is in your book. You can use those examples, those exercises in your book for indeed exercises. Can you try this? Can you try this? Before we move on to the next topic, can you try this? Just set up the integral formula. Set the integral formula. Hopefully you have got pen and everything. I will give you 2 seconds. Find the length of an arc of this from where x is equal to 2 up to where x is equal to 4. Hopefully you have got pen and everything. Just how many seconds do you need? Tavani, how many seconds? Mukise, how many seconds do you need? Just to set up the integral formula. That from there, the integration part, definitely 2 seconds, eh? Yes, because it's just straightforward. The formula, it will be S equal to the integral from A to B, the square root of 1 plus what? dy dx, all squared dx. That's all. Then from there, now you substitute now. That is the formula, in the formula. So what is A? Anybody?
2.
What is A here?
A is equal to 2 and B is equal to 4.
That's right. Therefore, it will be 2 up to 4. The square root of what then? This is 1 plus. And what is dy dx?
X
Dy
over,
dx, it will be how much? X over what?
over 4
Over 4
minus 1 over x squared.
minus 1 over x. What? Squared. And then dx, it will be this. Then from there, you can now play around with this. Play around with this and say, is this one standard? Is it standard? That is it similar to the one that we just did? The answer is no. Because if you take this as your f of x, what will be its actual derivative? Because remember, the one that we just did, it was something like this. It was something like this. It was something like this. So if you choose this, you are F. If you choose everything here as it is, as your F, and try to differentiate it, are you going to get 1 here? 1, which is this. The answer is no. Therefore, you need to maneuver this, manipulate this. Maybe it's not even going to be this one. So let's see. It will not be what? It will not be from 2 up to 4, the square root of what? 1 plus 1. Then you combine this. If you combine this, x over 4 and this, it will simply be what? 4x here, the LCM. Then it will be x minus what?
Minus 4.
Minus 4. All what?
Squared.
All squared. Then if you pause here, if you stop here, this is your F. Differentiate it. Is it going to give you 1 here? No, therefore you can't pause here, you can't stop here. Then it means you continue and remove the brackets here. What is x minus 4 over 4x all squared? We can just write the answer, né? What is the answer? It will be x squared minus 8x plus 16. Then that is, it will be, hopefully I won't forget, x squared minus 8x plus 16. All over what? All over 16, 16x squared. It will now be this. And if you pause here, will it become standard? No, it's still not standard. Therefore, you need to combine this and this. Now be what? Plus 16x squared here over 16x squared. You see. Then you combine these two. What? 17x squared. If you combine these two, 16x squared over 16x squared plus this, 16x squared, and this is 17x squared. Therefore, this becomes what? It becomes what? 17x squared it is, the square root of this. Hopefully this makes sense. And then if you stop here, will you be able to integrate this? Will we be able to integrate this? Then you can see that no. If you check in those techniques of integrals, is there anything that we can use for this? Clearly what? Clearly no. Then it means you still need to work this. Maybe complete the square. We don't know. You see. So then what will be the next step here? What will be the next step here? Anybody? Any suggestion? Any suggestion from here? What next now? Atazi? And definitely, then the best thing here is what? You then what? Say, split it. Say this is this, the square root of the numerator over the square root of the denominator. Then it will be this, the square root of this. You see. Then from there, you complete the square here. And now this becomes 4x in the denominator. It just becomes 4x. Then here you have now completed you have now completed the square root. Or otherwise, then you just complete the square root. No, complete the square. Complete the square here. Then you take the 17 out. Then you complete the square. Then it will be this. So on and so forth. And this is very similar to the one in the book. I'm not sure which page is it. Then from there, you can just go and mimic that one in the book. Then if you still have any question, you know my email address. You can just simply email me. Then I will then post the answer for everybody. I'm just looking at the time here, post the answer for everybody. Just go and try and finish it. But as I've said, the big elephant is this now, integrating this. It will need all those techniques and whatever. And then just go and try to complete it. If you can't complete it, whether today or tomorrow, then you just simply email me. Then, or the best thing is what? Email your solution. Then from there, I will correct you. But then in correcting you, I will post it for everybody on that portal. I will give you the solution on that portal. Now, the next question is, if there is no question, or the next topic is, if there is no question. The next topic is, any question before the next topic? The next topic is what is called the mean, or in brackets, the average. As always, start with something that you know and try to build up. What do you understand by this? The average. Say you have written tests, assignments, or whatever. How many? Say 3. You have written 3 assignments. The first one you got, second one maybe you got 70, and another one maybe you got 80. It's 3 assignments. And then they say they're going to take the average of your assignments. What will be the average here?
60%.
Anybody? What will be the average of this?
60%, sir.
Is it 80?
60.
Okay, now you have changed now. Yeah, 60 is right. Second time you got it right. Because the average, it will now be the sum divided by the number. It will be the sum of this divided by their number. It will be 30 plus 70 plus 80 divided by, very important, divided by their number. How many are they? They are 3. Then it will be this. Then it will be 180 divided by 3, which will be 60%. Therefore, the average is 60%. But what is important is what? These are discrete. You can count them. Test number 1, test number 2, test number 3. Very important. But now here, we are going to look at the average of something that is not discrete. You have this, y equal to whatever, x squared. Now you tell us this. How many values of x are from x equal to 0 to x equal to, say, x equal to 3? How many x are there? From x equal to 0 up to x equal to 3 when you are sketching this function. How many x are there? Anybody, how many x will be there? How many x? Nobody will say 3, né? Surely I'm just hoping, I'm just praying that nobody will say 4. How many are they? Let me just get an answer from anybody else. Remember, here we are all learners, né? You just try. Nobody will give you 0. Nobody will beat you. Nobody will what? Ridicule you. No. That is how you understand it. That is how we learn. How many values of X are there? But remember, the values of Y depend on the values of X. If there are 3 values of X, therefore there will be 3 values of Y. If there are 7 values of X, because each X is going to give you Y. The X is independent and the Y's, they are dependent on X. So how many values of X?
2, sir?
2. How did you arrive at 2, man? It's very interesting. I was thinking of maybe 4. How many values of X are there? Can you count those 2? Can you tell us those 2 that you got?
I was going if X is equal to 0 and X is equal to 3. So it would be 0 and 9. But
no, from X equal to 0 up to X is equal to 3. Remember, when sketching this, the graph of this is this. Now, this is from X equal to 0 up to X is equal to 3. So meaning in here, in this, that is in this, from here to here, how many X do we have?
3.
You can say 3.
Or it would be infinite between 0 and 3.
So,
You could have
it will
X
be
is equal to a half.
You can't count them. That's correct. You cannot count them. They are infinitely many. You can't say, unless if we are saying how many natural. Yes, natural, it will be 1 is a natural number, 2 is a natural number, 3 is a natural number. But then you cannot have a solid line like this. It will not be dotted. It cannot be solid. You see, from 0 to infinitely many real numbers, you cannot count them. And because you cannot count those X, therefore, you cannot count only values of Y, because each X is going to give you a Y. Because we cannot count the X, therefore we cannot count the Y. Remember, once you say X equal to 0, we're going to replace X here by 0 and get Y. Replace X by 3 and get Y. And by here, we mean what? The average of the values of Y. Maybe we didn't explain this. By the mean value, we mean the mean value of the function. And by the function, we mean the values of Y. The values of Y, which we obtain when we replace X by those infinitely many X. Because the X are infinitely many, therefore the Y's are infinitely many, therefore we cannot know their number. We can't even talk about this because this they will be coming from Y. And this we can't even talk about. Therefore, this formula has got its limitation. We can't use this approach now to find the average value of a function. And very important, it must be a continuous function. By continuous, we mean what? When you sketch literally, continuous, literally, not mathematically. Literally, when we say a function is continuous, we mean what? You don't lift your pen when sketching it. But don't forget, this is not a mathematical definition because this is not part of your syllabus. We cannot go into mathematical definition of what we mean by continuous. So by continuous, literally means what? Where you are not lifting your pen when sketching it. So here, this is continuous. Why? Because I'm just throwing it without lifting a pen from the beginning up to the end. But if somewhere I do this, and somewhere here I lift it and I start again somewhere, I lift it and start here somewhere. Therefore, this function is not continuous. Where it's not continuous here when x is somewhere here. Meaning maybe when x is 2, there is no y. And then it will be a gap here. Maybe we can use what? An open circle. And we're not talking about functions like this. And in fact, in all what we did with the areas, with the volumes, and with today's topic, we are not talking about functions like this, where there is a jump somewhere. I'm sorry, where there is a jump somewhere. So now, how do we find the average of the y's now in functions like this? Average, we mean that is the mean value. So that formula is there in your book. And is the one that is called that reciprocal. That formula is m equal to 1 over b minus a. That is where my initial 1 over b minus a comes from. Then it will not be from a to b, where we don't have to explain the b and the a. These are the limits. Good. What now? You just need to say y dx. It will be this. Hopefully that makes sense. Where y maybe is how much? Is x squared. We're saying from where? From x equal to 0 to say x equal to 4. Then that is something like this. Something like this. Find the length of, no, not the length. The length, we have passed it. Find the average values of y's from here up to here. Because there are y's here, there are values of y's here. If x is 4, y is 16, there is 16, there is 15, there is 14, there is, remember, there are infinitely many, because from here to here, there are infinitely many values of x, and from here to here, we know the extremes. The first value of y here, the last one is 16, and here there are infinitely many. But now what will be the average of all those values of y? And then that is the formula. Then you get it. And you know this formula. You know this. You know this formula. You know this formula. What is this formula? The one in red. What is it? We've said it gives you what? The area enclosed by this y and the x-axis from x equal to a up to x equal to b. This we know is the formula for the area, which will be in square units. Maybe this is 4 centimeters squared. Then from there, you are going to multiply it by this. From where x is, now this is, maybe it will be centimeters. This is centimeters. This is centimeters squared. And then you are going to divide it by something that is called centimeter. Therefore, the answer will be centimeter. Hopefully that makes sense. And once you understand it, then you can run with it. So what will be the answer here? Then I just plug it in from there. You can just finish it from there, because this in our case, it will be 1 over. So what is b? Is the upper limit. So what is the upper limit? Here is this. Therefore, it will be 4 minus, what is the lower limit? The lower limit is 0. From where to where? From 0 to 4. And what is y? Y is x squared. Then from there, you integrate this. The integral of x squared, you evaluate that from 0 to 4. Don't forget, then you multiply it by 1/4. Then that will give you the answer. We don't even have to finish it. It's straightforward. We don't even have to finish it. It's straightforward. That's good. Any question? Any question thus far? Any question thus far? Once you get the formula, then the next thing it will be is now. How do you integrate this? The integrand. Then it will be back to corner sessions. Now, look at this. We are trying to build for the next topic. We are trying to build for the next topic. Say you have got this. Y equal to, say what? Say sin x. Find the average. From where to where? From x equal to minus pi over 2 to pi over 2. From x equal to minus pi over 2 to pi over 2. Can you sketch this stuff? Just to have a more or less an idea of what are we talking about here. Can you sketch this? Y equal to sin x from where x is equal to minus pi over 2 up to where x is equal to pi over 2. Yes, straightforward. It will be this. It will be something like this. Say something minus pi over 2 up to pi over 2. This is minus 1 here. No. Pi over 2 here. And this is 1. This is 1. So meaning we must now find the average of the values of y. Remember, when x is minus pi over 2, when x is minus pi over 2, it will give you minus 1. When x is pi over 2, y, it will give you 1. Then from there, it will be those in between. When x is minus pi over 2, y is minus 1. When x is minus, you know them, those minus 4, minus pi over minus 6, whatever, because it will be minus 90 degrees, minus 60, the minus 8, the minus 45, the minus 20 degrees, 20 degrees, the 30 degrees, and what. So what is the answer? What is the m? That I just calculated at m. And this one, we need to finish it because we're going to use it for the next topic. Therefore, I think we need to finish this. So what is m? It will now be 1 over. Let us just make the substitute. We don't have to write the formula first and after substitute. No, let us just substitute straightforward. It will be what? The upper limit minus the lower limit. The upper limit is this. Therefore, it will be pi over 2 minus. What is the lower limit? Minus pi over 2. So which will be pi over 2 plus pi over 2, which will give you pi. So this, it will just give you what? Pi. Hopefully we're together. This, it will just give you pi. Because it will be pi over 2 minus negative pi over 2, which will be pi over 2 plus pi over 2, which will be pi. Now from where to where? From minus pi over 2 up to pi over 2. Hopefully you can see. Then you integrate y. What is y? Y is sin x. Then that is this. Then this is again 1 over pi over 2. Then the big elephant now, integrate this. And what is the integral of sin x? Is minus cos x. Then we just do this, and then from where? From minus pi over 2 up to pi over 2. And what is the answer? Just tell us the answer. Anybody tell us the answer? What is this? 1 over pi multiplied by this. What is answered? Do we even have to think? No, we don't even have to think. Why? Because what is cos pi over 2? What is cos pi over 2? Anybody?
0.
Is 0. What is cos minus pi over 2?
Also 0.
0. Therefore, the answer here is how much?
0.
It is 0. The answer here is 0. Okay, now let us take this further. I mean, if we are together, let us take this further and say y is no longer this, but y is for this. Y is for sine x. Can you sketch that graph? Y is equal to 4 sine x on the very same set of x's. Can you sketch it? Yes, from minus pi over 2 up to pi over 2. Can you sketch it? Yes, it will be something like this. This is now 4. This is now minus 4. And now the question is, what is the average of this now? What is the average of the values of this? Remember the big value here of 1. The big y value here is 4. It's no longer 1. Hopefully that makes sense. With the first one, the highest value of x, the highest value of y, it was 1. It's 1. Now here, the highest value of y is 4. And the lowest is minus 4. And there are infinitely many values of y's in between this 4 and minus 4. And what is the question? The question is what? Find the average of all those values of y that ranges from minus 4 up to 4. This one, it was find the average values of those y that were ranging from minus 1 up to 1. It gave us 0. But what about this one now? Where now the values of y now, they are now 10. Because if you continue sketching this, it will be something like this. It will be something like this. While with this one, it was going to be something like this. Meaning this one has what? Is between small intervals because it ranges from minus 1 up to 1. This one is now, the values are big, the intervals are big. It's from minus 4 up to 4. So what will be its m now? Let us just write it this side. What will be its m now? Let us just squeeze it here. But if you can't see, you tell us. It will still be what? 1 over pi over 2 minus negative pi over 2, which will still be pi. Hopefully that makes sense. Integrating from is still this. Integrating what? 4 sine x dx. 4 is independent of x, therefore you can take it out. Hopefully that makes sense. Take the 4 out, you write it here. Then this becomes 4 over pi what then? This now you integrate this. What is the integral of sine x?
Minus cos
it is
of
still
x.
minus cos x. From where to where? Minus pi over 2 up to pi over 2. And what is the answer then? This one, everybody knows it. This one, including myself. This one, you ask me, I will tell you the answer. This one, I'm telling you, Lerato, I will tell you the answer, this one. Manje, I will tell you the answer. Johannes, Mama Bulu, I will tell you the answer. What is the answer? The answer is still 0. 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 You see. So even if we can increase this and say 16 here, meaning it will still be this now, turning at 16 now. It will not have a bigger range. It will not be at minus 16 and what? 16. But guess what? What will be the average values of y's? They will still be what? They will still be 0.
0.
They will still be 0. But then, is it helpful? Can we plan on those values of y? Because maybe we're trying to do what? We are trying to construct a bridge. And we know, we want to know its maximum. We want to know its minimum or whatever. So you can see that this somewhere, somehow it doesn't work. Somewhere, somehow, it doesn't work properly. It's handicapped somewhere, somehow. Does it make sense? Before we move on, does it make sense? Yes, it does. What is the problem here? The problem here is what? Your values of y, they are oscillating between the positive and the negatives. Those positives and negatives, they will then cancel each other. The 1 and minus 1 will cancel each other, will give you 0. Half here, there is a minus half, which when you add them, because we have said your average you add. So if you add 1 and minus 1 is 0. If you add 0.9, if there is 0.9 here, there is a corresponding minus 0.9, and their sum will be 0. If there is 0.8 here, there will be a corresponding minus 0.8 here, whose sum then will be 0. So therefore, this somehow this is handicapped. Handicapped way, where your function, your y, oscillate between where your y takes the positives and the negatives, because those positives and the negatives, they are going to cancel each other. And then at the end, it doesn't give us a true picture of the average, because it doesn't matter what the maximum is. At the end, they are going to cancel each other. Therefore, it's not that helpful. Then how do we counteract to prevent a function taking the positive and the corresponding negatives? How do we mitigate that?
Need to isolate it to one part of the Cartesian plane.
No, yeah, it can be one part, it can be one approach. I agree with you. It can be one approach, but the perfect approach, it will be what? To square your function. Because by the function, remember, we're talking about y. So whether once you square the y's, so whether it was a positive or a negative, at the end, it will be positive. So then this now, let's talk about the first one, y equal to sine x. So, because we want to accommodate the maximum. So your graph now, instead of taking this shape, it will now take this shape. It will now take this shape. That is y equal to cos, okay, sine x. Here we have squared it. We have squared this now. This is this now. The graph of sine squared x is this. It's no longer taking a negative, because it will now be whatever x is here, then it will be -1. -1 squared, it will give you this. If you replace x by 60 or by -60, It will give you that minus half. Minus half, you square it, then it will give you a positive number like this. So if you have this, if you had this, y equal to, say, 4 sine x. So instead of this, it will now be this. It will now be this. You see. So now, because it's no longer taking the positives and the negatives, therefore we can find the average of those values of y, then they are not going to cancel each other. Therefore, they are not going to give us 0. Therefore, the average of this sine x and the average of 4 sine x, they are no longer going to be the same. This one, the average of this one, they're going to be more than this one. Meaning this one now has got what? Higher values of y. Then we can accommodate that in whatever model we are busy with. But if you have this, like the first one, if you have this and have this one, say y1, y2, and you have this, and you want to come up with a model that will accommodate both the positive and the negatives, and you want to use the average, then you are going to be in trouble because you won't know how high is this one, how high is this one, because at the end, the average, they are all going to give you 0. Hopefully that makes sense. So now to counteract that, then it will be the next topic. It will be the next topic, which is called the root mean square. Which is called the root mean square. Hopefully that makes sense. That is the root mean square. Let me just write it this side so that I can squeeze the formula. That is the root mean square. And what is it? This is 1 over b minus a, the integral from a to b. Now, instead of taking y, instead of using y, we square it so that your function doesn't take both the positive and the negatives. Then you integrate. Then, because we have squared now, reverse the square. Because now we have squared it. Then how do you reverse the square? Then you say the square. Then that is the formula. The formula for the root mean square is this. But you can just start with this one. Instead of using y, that is y equal to sine x, you square sine x. That is you square y. So here you don't write y, but you write the square of y. But we know it. How do you cancel that square? Then you must now say the square root. The square root of everything now. Hopefully that makes sense. Then from there, now if you have got y equal to sine x from minus pi over 2 to pi over 2, then what will be the answer now? You see, you are no longer going to have 0. You are no longer going to have 0. It will now give you a true picture of the average now, of those numbers now, and which will differ from the average of finding the average of this from minus pi over 2 to pi over 2. This and this, they are no longer going to give you the same answer. They are no longer going to give you all 0. No. Then you can plan and know that, oh, this one has got a bigger maximum, then you accommodate that maximum. This one has got a smaller minimum, then you adjust it properly. Unlike where it was just giving us that senseless answer. So what is this now? Don't forget, we can just start with the first one. But before we even go far, because, okay, let us just go a little bit far and see what is going to happen. Now, this is going to be the square root of now. We don't have to go back there. It will now be 1 over, we have said this and this, that is this minus this. We have said it will be over pi. We don't have to go back there because it will be pi over 2 minus negative pi over 2, which will be 2 pi over 2, which is this. Integrate from minus pi over 2 up to pi over 2. Now here, instead of writing sine x, then it will now be sine squared x now. Then what now? Dx. Dx is inside. It's the square root of everything. Dx is not outside. Dx is inside. Then from there, what do? It will now be the integral of, that is the square root of 1 over pi over 2, then the big elephant, this now. How do we integrate sine squared x? And that is where we know, okay, a square of how many trigonometric functions do we have? There are 6. 6 trigonometric functions. Therefore, 6 squares of trigonometric functions. Which one are standard? Because we have got sine, cos, tan, whatever, until there are 6. 2 of these 6, they are standard. Because they can be derived from, because they are the derivative of some other functions. And we know the next 2, they are not standard. But we can use the standard, but they can be written using those 2 standard. Then the last 2, they are just different altogether. Which 2 are standard? We said there are 3. 2 are standard. 2 they are not, but they can be written using these 2 which are standard. Then the last 2, we know they are not standard. They cannot be written. The first 2 which are standard. Now we have got another technique of integrating them. Our question is, which 2 trigonometric are standard? I'm talking about the squares. Which 2 are standard?
Sine and cos?
No. I'm not sure whether you understand my question. We have got what? Sine squared. Let me just say integral of this. We have got the integral of cos squared. We've got an integral of what? Tan squared. Integral of their reciprocals. Let me not go there. Okay, let me just write them. Cos squared x. What? Sec squared x. What? Cot squared x. There are 6. Which ones here are standard? Meaning they are the derivative of just standard trigonometric functions. Which one here are standard? We can just write the answer. Any question or any answer? What is the derivative of tan x? What is the derivative of tan x? No, tan x, not tan squared x, tan x. By the way, dear students, yes, we know we are going to be given that formula sheet, but you cannot depend on that formula sheet for each and every differentiation, for each and every integration. Some they are standard, you just have to write them. Even if you are looking for an answer, but then you must know where to find that answer. You cannot page through the whole booklet, page from 1 up to 3, or from 1 until the end. You must know where to find it. And many of them, you don't even have to go there. You must know it. What is the derivative of tan x? I heard a voice. What is the answer?
Sec squared x.
Is sec squared x. This is how much? Is sec squared x. Therefore, the integral of sec squared x is tan x. Therefore, the integral of sec squared x, this one, therefore, is standard. Because sec squared x is the derivative of tan x. And which one else is standard? Which one else is standard? Sec squared x is standard because sec squared x is the derivative of tan x. Which one else in the remaining 5 is standard? Is how much? Is cosec squared x, because the derivative of cot x is minus cosec squared x. The derivative of cot x, the derivative of cot x is minus cosec squared x. Therefore, this is standard. The answer is minus cot x. This is standard. Let me just tick it. This is standard. We don't have to check the book. Now we have got what? 4 left now. Now, what about this one? Cot square x. What about this one? Tan square x. Are they standard? No. Because there is no trigonometric function whose derivative is tan squared. There is no trigonometric function whose derivative is tan squared x. Therefore, to integrate tan squared x, you have to do some manipulations. So what do? It's very simple. Why? Why? Because you can write tan squared using sec squared. Sec squared, which is standard. Now we are going to write tan squared using sec squared, which is standard. Then we're going to say integral of, instead of tan squared. What is it? Let's solve this. We know from sine squared x plus cos squared x. If you divide throughout by cos squared x, divide throughout by cos squared x, divide throughout by cos squared x, divide throughout by cos squared x. This divided by cos squared x is tan squared x. This divided by cos squared x is 1. This divided by cos squared x is how much? Is sec squared x. Therefore, if you take this, then this becomes sec squared x minus 1. Then this one is standard, is tan x. This one is x. Therefore, you are done. The same thing with this one. 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 It's not standard because there is no trigonometric function whose derivative is cot squared x. There is no trigonometric function whose derivative is cot squared x. But if you come here, sine squared x plus cos squared x equal to 1, still divide throughout by sine squared x, divide throughout by sine squared x, divided by sine squared x, 1, divided by sine squared x is cot squared x, divided by sine squared x is cot squared x, and divided by sine squared x is cosec squared x. Therefore, cot squared x is cosec squared x minus 1. Then it will now be cosec squared x minus 1. And cosec squared x, we have said, is standard. The integral of this is minus cos what x, and this is minus x. So then now we are left with only 2 now, because these ones, they are not standard. This is not standard. This is not standard, but we can use, you can write them. This is not standard, but you can write it using this. This is not standard, but you can write it using this. But now, what about it? The remaining 2 now? That is these 2. That is this one now, because sine squared x, sine squared x. How do we integrate this? We know we are going to use what? That of cos 2x. We are going to use that of cos 2x. Cos 2x. We know cos 2x, although we are now wasting time now, is how much? Is cos squared x minus sine squared x. We know is this. Therefore, cos squared, okay, therefore sine squared x. Therefore, what is this? You just have to write this now using sine squared x. This is cos squared x is this. Therefore, then this becomes it is. You don't even have to go there. Then what is this? Because we're not going to bring this together with 2 this side, and this comes this side. Therefore, this now, that is this, becomes what? Half in brackets. Remember, you still have this here. You still have this. Then it's half in brackets what? 1 minus cos 2x. This. You have this now. Then we know what is the integral of cos x. What is the integral of cos x?
Sine of x.
Is sine of x plus c. But because it's definite, we don't even have to include it as c. Then what is the integral of 2 here? Cos 2x. What is the integral of cos 2x? Is how much? You can't say sine 2x, ne? What is the answer?
Half sine x.
That's right. It will not be what? Half sine what? Sine 2x. Because we are now using this. We are now using this formula. This formula. We are now using this formula. This is cos, and your f is 2x. Your f is 2x. Therefore, according to this formula, you need the derivative of 2x here. You need this, which is 2, then you write half outside. Therefore, the answer it will be half. This half is this half. Then you write sine 2x. Then from here, you can now get the answer. Now, from here, you can just simply go straight to the answer. Go straight to the answer. Hopefully, it makes sense. It will now be the square root of 1 over pi. Then you will now take the 1 over 2 out. Because the 1 over 2, it doesn't depend on x. Then you can just simply bring this. Then you write it. But don't forget, it's still within, it's still inside this. Then you write this. With the integral of 1 with respect to x, it will be x. And what is the integral of this? It will be minus half sine 2x. Minus half sine 2x. You evaluate it from where? From minus pi over 2 up to pi over 2. Then the answer is going to be positive. Then you take in square root. Then it's not going to give you 0. Then it will give you an idea now of what? The average between the maximum and the minimum. It's not going to give you 0 like the first one. But, if you look at this, if you look at the amount of work that goes into this, especially this radical sign, the first step, radical sign, the second step, radical sign until the end. How many radical signs are you going to write? It will depend on how many steps. And what I know is there are going to be many. So therefore, you're going to waste a lot of energy writing the radical sign until the end. Then how do you mitigate, how do you counteract these many radical signs? You just square right from the onset. You square both sides. Then the left is going to be the squared. Then the right side now, it will now be without the radical sign. You are no longer, once you write a squared side, then this is the radical sign, it will fall off. You are not going to write it all the time, until you get the answer here. If the answer here is 6, this 6 is not the final answer. It's not the root mean square. Is the square of the root mean square. 6 is not the root mean square. Is the square of the root mean square. And the question is not finding the square of the root mean square. The question is find the root mean square. Then how at the end then, if this is 6, therefore you're going to say, therefore RMS now is now the square root of 6. Then you write the answer. You don't have to write square root. How many times? 10 times, because you have got 10 steps. Hopefully that makes sense. But don't forget, if you square this, don't forget and leave your answer as just the 6 and 6 is the final answer. Otherwise, you're going to be penalized. And when they penalize you, it will depend on the marker. The marker can subtract 6 marks out of 7 marks. You see. Hopefully it makes sense, Helen. You can just finish it. Go and finish it. And let us look at another one. Go and finish it. Because from my guess is everybody will be able to get it. And if not, you can just simply compare it with what? Say y is equal to 4 sine x. That is, compare the answer for the root mean square of sine x. The root mean square of sine x. And what? The root mean square of 4 sine x. The average, we saw them. They were equal. They are equal. The average, they are equal. They are all 0. But what about the root mean square? You will see that they are no longer going to be the same. It will give you more or less now the maximum and the minimum. It will give you the true average, not just 0. And we know it's not 0. So we have said to mitigate that 0, then you do that. Hopefully that makes sense. Any question? Any question before we look at another question? No, I don't have anything here. I did not write anything here. Did I write anything here? No, because those questions in the book are quoting to us. Once you understand one, you understand whatever, then from there it will be your integral knowledge. Or do you need another example or anything? We can just talk about anything now from these 2 topics. Anything that you need us to revise? Mahatu, is there anything that you are still not sure, Brenda? Is there anything that you are still not sure of here? Or maybe you do have a specific question. It's either from the activities, from the exercise, or from the past question paper. Yes, we can look at. I think we still have 3 minutes, 4 minutes. We can look at that. Mlambo, do you have a question?
No question for me, sir. Thank you.
Anybody, any question?
No questions from my side, sir.
Larado, do you have a question today? Don't forget, you have never asked me anything.
No.
Say,
Yes, yes.
yeah, afterwards, when I look at this, maybe after you posted this video, afterwards, if I
Come
have
again.
questions-
Come again. Take it
So-
slow.
Yeah, okay. After I have reviewed this, let's say, after watching this video, after you posted, if I have questions, am I able to post it? Where do I post those questions?
Yeah, I think we have said it this right at the beginning. Maybe you joined us late, Mahatu.
Yeah,
We have said what?
I did.
We have said what? Any time here is tea time.
Okay, so I can always
Any
post
time is
questions.
tea time.
Okay,
After
okay.
watching this,
Yeah.
or what? We look at a question on the assignment. No, not the assignment directly, ne? Because I'm not allowed to answer a question directly from the assignment. Because what I'm saying is what? I will then not just respond to you directly, post the solution on the portal. So
Okay.
please don't ask what a question from the assignment. It
No,
must
I
be a
want-
question.
So, but then, how do I post this question? I'm posting them right here, like on Teams, or how do I post it if I have something to ask you?
No, I'm saying post it on the portal or whatever.
Okay.
That question, it mustn't be a question from the assignment.
Yes. So
Because then I
got
will
you.
now be
Yeah,
giving you the
I-
solution. That's
Yes, I
how
understand.
I'm saying, whether it's from the exercise in your book, whether it's from the activity, or whether it's from the past question paper. Yes. Then from there, I won't answer you directly, but I will put it on the portal, the solution. But it's always better to what? To give me your solution. So that, because in many instances, you may find that your solution is correct. The only issue was what? You were maybe you were not aware that your solution is equivalent to the one that is provided in the solution, or what? Your answer is exactly the one, or maybe whatever, because some students may find that their only error is what? Like with our first example here. I used the wrong formula for the arc length. Why? Because in the book, the first topic is what it was about, the average value. In the book, the first topic is the average value. But then with me, I said, but what will be, according to my approach, how do I approach these 3 topics? I said, no, it's better to start with the arc length. So, but now, because in the book, the first topic is the average, then I used the formula for the average value, calculating the arc length. You see, it's just a question of the formula. Then I will tell you that, no, you use the wrong formula. The correct formula is this. Then from there, you take it. Do you see that? No, you are not that far. It's just that you missed the formula. So that is why I'm saying it's better to show me you are working. Then from there, I will see where you got it wrong, your misconception, and whatever your error, and then I will correct you. But still, post it on the portal. Because you may not be the only one who is struggling with that problem. There are many. There may be many who are struggling with that problem, but then they were shy now to ask. Then it will help many students. You have a question now, Maloba, today? Mapala?
Another question, sir.
Hopefully after, but did you go through all the videos, the first one and the second one? No. I'm answering for you, ne? No. Then go through them before it's late. So if nothing, then we can call it a day. Now, but before we call it a day, let us just, try to introduce you to the next topic, which will be Saturday. Same place, same time, God willing. We have said it is. Differentiation, to be honest, the differentiation is a straightforward process. Let me repeat this. Differentiation, it doesn't have many techniques. It's a straightforward process. If you can't differentiate, you have to think twice. Now, what about the reverse? Integration. Integration is not a straightforward process, I'm telling you. Some integrand, they are standard, meaning they are straightforward. Why are they standard? Because they're the derivative of some functions, like this. Say the integration of x with respect to x. This is straightforward. It's standard. Is what? It will just be x squared over 2 plus c. It's straightforward. And there are some integrand which are not standard. Like what we have said, the integral of sine is not standard. Why? Because sine squared is not the derivative of any function. It's not the derivative of any function. Then you have to think twice. Although some students here, that is where we're saying sometimes if you don't understand mathematics, then it becomes very simple. If you don't understand it, then it becomes very, very, very simple. You will even be surprised and say, but these guys, why are they worrying? Why are they thinking? This is simple. Why? Because some students, they will then use this. They say, but this one is equal to this one. Therefore, this one, it must be equal to this one. Then what are these people thinking of? Because this is very simple. This one is this, that one, this one is this one. Then from there, you see somebody writing this, smiling and say, but then come the feedback, then you see something else. This is not standard because you can't use this. Because for this, we are using the power rule. For this, you are using this, the power rule, x exponent n, this, and this is just a monomial x. But then this one is not a monomial x. This is a function. This is a function. And this is just a monomial. Even if you have got what? Even if you have got what? Even you have got the integral of the square root of x, this. Say 3 here. All what you can do is what? Just say this is the square root of 3, then multiply it by this. Now from there, take the square root of 3 out. Take the square root of 3 out. Then from there, to integrate, then it will be the square root of 3. Now to integrate this, you are now going to use the power rule. then you get it. There's no problem. But what about here? You can't use this technique here. You see. Therefore, it's not straightforward. And worst part is that some integrand, they are not even integrable. You can't integrate them, no matter what. You can't integrate them. But what about differentiation? You can differentiate all functions. Literally, you can differentiate all functions. But what about integration? Some, they're standard, meaning they're simple. Some, they are tricky. You have to use some techniques and whatever, rewrite it in another form, but at the end, be able to integrate it. Now, the last group of integrand, you can't integrate them. They are not integrable at all. They are not integrable. You can't integrate them. But then the question is, we have said it is. We have said it is from 0 to 1. How do you interpret the answer? Not even how do you arrive at the answer? No. Let us assume you have arrived at that answer. Then how do you interpret it? Any question? No, any answer? How do you interpret the final answer? Say the final answer, we know this, it will be x squared over 2 from 0 to 3, which will be 27 over 2. How do we interpret this? You can't just say it's the answer. It has got meaning. How do you interpret 27 over 2? Anybody? Mahato, how do you interpret it? What does it mean to you? Don't forget, this is the area of this. It will be this. From 0 here up to 3. This is the area of this. This is the area of this. Is the area of the region enclosed by y equal to x. Of the region enclosed by y equal to x from x equal to 0 up to x equal to 3. Meaning that the area of this region enclosed by this, and the x-axis, I've forgotten, is the area, the area of this triangle. This. Now the question is, what if this is not integrable? What if this is not integrable? This integrand here is not integrable. The question is, then can we find this then? The area enclosed by a function which is not integrable. Can we find this area? Guess what? With mathematics, we can still get it. Although this is not integrable, but we can still get it. The question is how? Is next week's topic. But the answer is not going to be exact. It will be the approximation. That is the next topic. We are now going to approximate the area of a function which is not integrable. Although we cannot integrate it, but at least we can approximate the area enclosed that function and the x-axis in a certain interval using those methods. There are 3. That is next week's topic. That is the approximation of the areas. Hopefully, just read it like you are reading a WhatsApp or reading like a newspaper or what. You don't have to understand them. No, just read them. Then from there, it will now make sense. Next week, Saturday, same place, same time. Then we are going to look at those. There are three methods. It's three, yes, it's three methods that one can use to approximate. But please, in the exam, answer the question, because the question may be specific and say, use this method. Then you use it. Or use this method. You use it. You cannot use A when the question is asking method number B. Then you are out of order. You will get 0. So you have to know all of them. Any question before we go? Helen, any question? 3, 2, 1. No question
from me,
from
sir.
Helen.
Thank you.
Any question? No question from me. Then
No question.
see you next week, Saturday, same time. I'm forgetting.
Next week it's a
Please,
holiday.
come again.
It's a holiday. Are we gonna have a class?
So
I'm
the
just
holiday
asking.
means. Let me get
It
you,
means they
Helen.
don't
Let me get you, Helen, properly. Holiday means what? No work, no eating.
No work, but we eat.
Yeah. You cannot eat without working, Helen.
Okay.
So definitely,
next
I'm
week.
not sure. It will depend on the dear doctor. If the
Okay,
dear
no
doctor
problem,
say,
sir, it's fine.
otherwise, then we will schedule it before the holiday. Okay, let me get it from Helen. If we schedule it before the holiday, will it be fine, or you want it after the holiday?
And any is fine, sir.
Before or during or after? Which one? Any?
Any.
How is
Yeah,
your
yeah.
schedule, sir?
Dr. Tamin will tell me.
Okay.
Maybe there's a precedent somewhere. During holiday, we don't have class, but today is a holiday for some because it's weekend. Because you guys, I'm told that no, some of you, this is part-time or what, and we cannot have class during working hours. Then holiday is after work, is after hours. Then okay. Then I will talk to doctor and then see when we can schedule it. So thank you very much and see you. I'm not sure whether to say Saturday or Friday or Sunday. I will talk to Doc and then we will put something on Tuesday.
Okay, thank you, sir.
Thank you
Thank
very
you,
much.
sir.
Thank you, sir. Have a good
And
one.
bye.
Thank
Enjoy
you,
your
bye.
holiday. If we schedule it after the holiday, enjoy your holidays. Bye.